Okay, hi and welcome to Notes 3.1, which we can see here. We're going to do a quick talk about inequalities and we'll talk about the graphs. So let's get right down to it. This should be something that you're familiar with at this point, nothing brand new. If it is, that's not too bad because it's pretty quick to pick up, so you're going to be right on pace with this. So, an inequality, we know what that is, right? That's those fancy symbols you see right here. What it means is a solution set. It's more than one solution. When we talk equal sign, right? Equations, there's one generally, we'll say that one solution. For us, we're just going to say one solution right now. We're going to keep it super simple. But with an inequality, it means a whole bunch. It means that you've got a point or a boundary, and it means a whole bunch of solutions, one way or the other. So that's what I want you in your mind. It is a bunch of solutions. All right, bunch right here, bunch O solutions. And that's what we're going to be talking about. So it compares, if we finish off the definition here, just to make sure we cover everything on it, it says a mathematical sentence that compares the value of two expressions using an inequality symbol. Again, what you're getting out of this for our terms is it's a bunch of solutions. It's never just one with this. All right, let's get down to it. You should be familiar with these symbols here. That's a less than, we know equal, greater than. Let's just clarify that from left to right as we read. I remember always thinking about this when I was in high school, that if it's left to right and it's the pointed side first, the tiny side, that is less than. So if you see it that way and you always forget which one it is and you're thinking the alligator, well, the alligator eats the larger thing, that's the teeth. I mean, you can do that. That will always work depending on how you read it. But since we read left to right, if you see the pointed side first, that means it's a less than. And if you see the open side of the alligator from left to right when you read it, that means greater than. Okay, that's what I remember in my head when I read these. Okay, so now that we got that down, a solution, which is what we're talking about, it's got many answers. A solution of an inequality is one that makes the statement true. What does that mean? It means when you plug the numbers in that it makes sense. So yeah, it works. Okay, I don't know if there's a simpler way to say that. So let's get down to one and see if we can see what that looks like. This one says, is each number a solution? So when you plug in this number here, number 9, into this inequality here, does it make sense? That's what it means, does it make the statement true? If it's false, it means it doesn't make sense. So if we take a look at this, we're going to write it down. This is our good behaviors. We're writing it down, even though we can do this in our head. We're going to do this on paper so somebody can follow it. We can look back. We can see what we did. We can see any mistakes. And that's really what this is all about, right? So I write that in there, except for an X, right? This is going to replace X. So instead of being X, it's going to be 9. Is this true? So if I read it from left to right, this is a less than sign. Is 9 less than or equal to 7? Well, it's definitely not less than. Is it equal to 7? Nope. So it doesn't fit either of those. So we're going to say not no, right? A lot of kids will write, no, it's not a solution. We're going to write not a solution. We're actually going to take the time and say it the correct way, which means that that's not in its solution set. So you can see a couple other examples here. If I plug -1 in there, -1 is less than 7, so that's a solution. 14 halves. Mr. Hallam, no fractions. Well, fractions are okay, especially this one, since it's just 14 divided by 2, which is 7. Which brings us to the point, it's not necessarily less than, however, it is equal to, so it does qualify as a solution. All right, so what happens if you get something a little more complex? You get an expression on one side. Here's an expression that's greater than 13. I mean, 13 is an expression too, but this one really looks like it because it's got a variable in it. So what do we do here? Same thing. You take whatever number they're asking you is a solution. You're going to plug it in. Hopefully it's one variable, so you can solve it. If it's 2, you need a little more information, but that'll be later. So we plug that in. You can see it went in for x right there. And then you go ahead and work it out using order of operations, right? We'll talk about the difference with solving. That's reverse order of operations. You are not there yet in my class, but you will be very soon. So order of operations says we have to deal with this multiplication before that subtraction of this term from the 2. So -5, we like to think of this as a -5, not a subtraction sign, becomes -15, right? -5 times 3 is -15. Go ahead and combine a +2 and a -15. We get -13, and we've got -13 is greater than 13. Not true. So if it's not true, we say not a solution. So let's do another one over here. I'll actually work through this one with you. So I'm going to zoom it in a little bit. So I'm going to rewrite my expression because that's how you should always do it. When I rewrite it, I'm going to go ahead and plug in my new term, which is this negative 4. So instead of x, I'm replacing negative 4 here, which is greater than 13. Well, let's work through it. Order of operations. Ooh, in other words. Okay, so nothing happens to the 2. Remember, I like to work vertically, so they just drop down if I don't do anything to them. Negative 5 times a negative 4 makes a positive 20. So now I've got 2 plus 20 is greater than 13. I'm going to go ahead and combine those last two terms. 20 is greater than 13, so this is a solution. Solution. We found it. So that means that it's part of a solution set. What does that really mean? Well, let's take a look over here at what it means to graph it, because we'll visualize some of these and you'll get a better idea if you're not with me already. So this says graph, which really to us means take a look at what it means to be a solution. First thing I want to point out is I like to use the idea of thinking of whatever is on the opposite side of the inequality, especially when we have a variable, right? If it was another number, it's a true statement. We say yes or no. Is that a solution? In this case, it's saying, what are all the possible solutions for this simple inequality? C is greater than negative 2. So you take your number, you think of it as a boundary, you identify it, which brings us to, remember that if an answer is included as a boundary or not included as a boundary, this is how it goes. Okay, so if it's not included, it will be a less than sign or a greater than sign. When you mark your boundary, you're going to say it's an open circle, meaning that that is not part of the solution, but everything on either side could be. Everything as close as possible is not a solution. I mean, you could have the decimal right next to that number, and it's not a solution. This particular number isn't anyway. If it is included, you'll have the equal sign underneath, and that is your darkened in circle, indicating that that number is also part of the solution set. So let's take that back over here. There is no equal sign underneath this greater than sign. So we're going to go to the boundary first, and we're going to recognize it. We're going to leave it open, indicating the fact that that is not a solution at negative 2. And then we're going to go ahead and mark the rest of the graph. The way that works is, wherever your variable is, this says that this c is greater than this negative 2. So this really, when I word this, I say, my solutions, that's how I say it in my head sometimes, my solutions are greater than negative 2, which tells me which way to go. Because if they're greater than negative 2, that means I got to go to the right. So all the solutions, every point possible that I could find and identify along this line forever and ever and ever, all the way out to infinity, never ever stopping, are solutions. But negative 2 is not. So, I mean, I could get right up close that I could say negative 1.999. And again, I could do this forever. And as close as I wanted to get, 2 is still not a solution, but everything right up into it is. That's what that's saying there. So, and everything obviously on this side is also not a solution. Nothing less than negative 2 is a solution either. All right, is that kind of giving you an idea? Well, let's take one look at number 7 here, see if we can do the same thing. I'm going to pause because I'm probably going to ask this question in Edpuzzle. All right, now I'm going to continue because my pause is over. So I'm going to identify my boundary, in this case, 4. I'm going to look at my equal sign. Yep, it's got an equal sign, so I'm down here with included. So I'm going to go to 4. I'm going to make a circle, and then I'm going to color it in. It says 4 is part of my solution. Now I'm going to look at this. I'm going to circle my variable. I'll scribble it over here. I'm going to say my solutions then are, this is a greater than sign, right? So greater than 4. So I'm going to identify 4. I'm going to go greater than 4, and those are all my solutions. This time, 4 is a solution, right? So all the non-solutions start at 39999 and forever less than that, right? So these are solutions. Does that kind of make sense? So what this says, if you retract a little bit, I don't know. That's good enough. We'll leave it at that. All right, so here's a couple other ones. We're going to do the reverse this time, though. Last couple questions. So we graphed from an inequality. Now we are writing the inequality from the graph. So I'll leave these up. You can write those in and kind of follow them on yourself. But first things first, identify your boundary. There's my boundary. So I'm going to write my boundary. It is negative 4. Now I'm going to look at my solution set. I'm going to pick a variable, probably x. And then my solutions are everything less than 4. Now, if I want to put the x on the left, I have to pay attention to my sign. Otherwise, I put the 4 out and then I adjust it. So the x can be on either side for us. So you can see I've got 1 on the left here, 1 on the right. As long as you get your inequality right to represent it, it doesn't matter which side that you write it on. Is there a rule? Yeah, we'll leave that for a little later. For right now, there's a preference, but neither of them are wrong. Either way is really fine in this case for us. So we know that it's an open circle, so we're going to have a less than or greater than sign, so we need to figure out which way it is. This seems to be all the solutions less than -4, so I want to say that this is a less than sign between them. So my solutions are less than, because it's pointed side first, right? Less than -4. I can read it backwards if I want. I can read from right to left. I can say -4 is greater than all my solutions. I don't prefer saying it that way. My head doesn't like it as much, but it still does work. But notice how I said -4 is greater than. So from reading from right to left, I hit the open side first, so I call it a greater than sign. That's why I said when we read from left to right, which is generally what we do, the pointed side comes first. I like to say a less than sign. Hopefully that clears up any issues that you have there. All right, so there's our notes. Let's recap. You found out what a definition of an inequality is. We talked about what a solution was. We found out if a number is a solution for an inequality. We found out for a more complicated version of it, which would be here. And then finally, we started graphing them so we could look at the solutions. So that's 6 and 7. And the last bit that we did was writing the reverse, taking the graph and writing as an inequality. And again, remembering this information that we may have been a little rusty on. All right, at that point, I think we're done. There's your homework. I'll see you in class. Thanks for watching my notes, and bye.